Hi, good morning, everyone. My name is Ariana Statham. I'm part of the operations division, and I'm here with some of our chief scientists to discuss rapid prototyping. So, very obvious question to kick it off. What is rapid prototyping, especially here at Coreforce?
Well, I'll take that one. It's obviously two things, speed and it doesn't work. The idea that Todd said earlier that fail early, fail often, I think is something we don't take into context well when we talk about prototypes. And it's difficult when you're doing something as a rapid prototype that you produce very, very quickly and you hand it out to a customer community that they expect it to be production quality and it's not going to be. So that realization and that balance between getting something done quickly into the hands of the users who can make use of it and getting it to good enough quality that it's out there quickly is a very, very difficult thing to do. So when I think of rapid prototyping, I think of speed is don't expect it to work. Or at least perfectly, I should add.
Okay, you're looking at me, I'll take it now. So one of the things that I've always been fond of saying is that the existence of the system changes the requirements of the system. Once somebody sees it, there's always going to be somebody in a crowd that's like, gee, wouldn't it be great if? And we go from there. And the problem is, and Scrum addressed this with the technology of the time, where instead of these, 9-month-long development cycles where there are huge PRD documents and, manage huge pipelines and all that stuff, where when you find a defect at the end, it's now a huge cost to go back upstream and fix it. And that just delays a product so long that by the time it's ready, it's like, what did we want again? That doesn't meet what we need. The sooner you get something in front of people, the sooner they help refine it. If you just talk about something, gee, it's going to be great when, you don't quite get the feedback that you get when there's actually something to kick. Right? So the idea of rapid prototyping is to get, you don't have all the answers yet. You purposely don't have all the answers yet. You make a lot of assumptions and you get something together. And it used to be, it still is, I think, in most organizations, that you give it to a dev team and you give them a couple of weeks for a prototype. And they are still going to get bogged down in how are we going to manage our users? How are we going to do this? How are we going to do that? And one of the both blessings and curses of what we can do with AI right now is that I give it a prompt. Sometimes it's too eager to try to deliver something based on that prompt. And you get this prompt, and you know what, if you don't know what you want, something that an AI generates in 5 minutes looks awesome. You're like, it did that in 5 minutes? That's great. Now the catch is, you got to start throwing the arrows at it. You got to start putting it in front of people and getting the feedback. And you're like, well, gee, we don't need a whole system to manage users that it baked in because we're going to tie it into our single sign-on service. So that stuff goes away. Gee, we don't need to manage that because we're going to get it from literacy data. So that part of that thing goes away. But we really need it to do this thing. So then that starts to come in. The whole idea of rapid prototyping is to get something wrong in front of everybody quickly and then let them start to kick it apart. Now, the dangerous thing is when that collides in a world where people start using the term functional prototype, right? I've always hated that phrase. I remember saying to somebody, what do you mean functional prototype? I want you to write a publishable first draft. It's like you turn it into English and people are like a writing assignment, people will push back. But for some reason they think, 7 people working on a team for 2 weeks can make something that is a publishable first draft. It doesn't always work that way. Even now with AI doing a week's worth of work in 20 minutes.
So I'll agree with both what Dave and Jackie said and kind of expand on it a little bit of what rapid prototyping really kind of means to me. And it really is kind of a new medium that we can get in front of people. The age of PowerPoint is dead, right? To throwing out, like, oh, this is vaporware, this is what we can do, right? Being able to take and iterate on something in 20 minutes and creating, something that's not perfect, but can at least convey an ideal to a customer or to somebody else that they can sit and they can click through and they can view and they can see an actual demo of it and be like, oh yeah, okay, now let's really dig into requirements and kind of see what these next steps would really look like, right? It shows the level of engagement and investment on our part that our customers can then take and say, okay, now they have skin in the game too. They don't know if that took us 20 minutes to make or 2 hours or 2 months, right? To them, it's just something that we're doing in order to, kind of make their problems easier. And also, we talk about fail fast, right? But you have to also not be afraid of failing, right? Everybody is so risk adverse to failing, right? And that's not what engineering is. That's not what innovation is. Innovation is failing, right? It's just you fail so much, you figure out a way to do it. So, and we were talking earlier, you have to get out of that, mindset of if I fail, I'm going to lose my job, right? And that's not the culture we want to build. We want to build a culture where we're like, okay, try things, try things, try things, try things. Oh, okay, you found that diamond in the rough, right? That is what's going to move the needle. That is what's going to be, the best thing. And I've been in many industry days where the government is like, we're no longer interested in incremental improvements, right? We don't want you to bring something to us that's 5% better. Oh, you added a new budget, or button. Oh, you added a new widget, right? We want you to bring something that's, 120% better. That's what we'll invest in. Right. That's what we want. And that's kind of what we're building towards, is really trying to move that needle very quickly, get it in front of who it matters and who it's going to help, and really bring that innovation forward.
Awesome. Last year was our first innovation challenge. What do you think that internal test kind of revealed about CoreForce's ability to move fast and iterate?
So I think, and I think we were all part of that in various ways. I think our real insights from that challenge were, we know that we're not going to be able to do this all ourselves, right? And the innovation challenge was set up very much, we were going to throw people into the fire and just let them see what happens, right? And see what people were capable of. What we didn't tell them what tools to use. We gave them a basic format, and we're like, bring us a solution and create a video, and also you're going to have to do this in a week, right? And it's very much the situation that we see ourselves with CSOs and OTAs, right? Where they want to have something delivered to them in a 2-week period. And so we wanted to see, like, where we're at in the company are these people that can, engage outside of who we typically turn to, because we typically turn to, chief scientists or, other like senior trusted engineers to come up with some of these solutions. And there's innovation all over the place. Every single person in this room is an innovator in their own way and can come up with new solutions, right? And we're taking away that traditional barrier of entry of being able to put hands on a keyboard and software and things like that with the power of AI. So that, I really think that is what was the crux of the innovation challenge itself, was starting to reveal who those real innovators are, right? Who we start to reach out to, how we expand the team, how we really make this a whole company effort as opposed to a concerted effort by just a few people.
I could pick up on that a little bit. One of the things that impressed me the most about that innovation challenge last year was, in reviewing the responses, I kind of grouped people into 3 categories. We had professional engineers, some of whom are in this room, that participated in that challenge. We also had students that are still going to school and trying to graduate. And what I found to be interesting was, in one category, there were the students that said, this is just another college exercise, and they started on it the night before it's due. And they did not fare well. Then there were those who did a very polished job, not so much in the approach that they took was better than anyone else's, but in terms of foreseeing and understanding what all the features needed to be. Because we might run into this situation, or we might run into that situation. Those are our professional engineers. They did quite well. They had the advantage of understanding the domain. Then that group that was in the middle, the students who took it seriously, I was blown away by what they came up with. And their solutions were in many ways as good as the professional ones. And the only thing that they lacked some mature guidance to show them, you need to consider this as well, because that's something that's in the real world you're going to have to deal with. And because they took it seriously, I was absolutely stunned by what they were able to accomplish, not knowing diddly squat about the domain. And that to me said that for those students who are matriculating now through our colleges, they're getting the basic technologies down correctly, and what they're missing that all of us need to provide them is the domain guidance to understand the other things that will be in the problem space that they'll deal with. And one of the persons in this room that was involved in it, you know, you did a good job, but you got people nipping at your heels.
Project literacy is a perfect example of rapid prototyping and how we've been doing that for ourselves. What lessons have we learned from that so far? And how can we make those lessons applicable to customers when rapid prototyping?
You don't mind, I'll start with that one. It's true that in any system where you have things that talk to another and go down a pipeline, there's always a bottleneck, right? Maybe you've read Eli Goldratt and the theory of constraints and, you know, queuing theory and all that kind of stuff. There's always a bottleneck in every system, right? If there wasn't, things would be done instantaneously. If you move one bottleneck, if you solve that bottleneck, give something more capacity, the bottleneck just moves someplace else. For a long time, the bottleneck has been the functional unit of a delivery team, you know, a couple week sprint, an iteration, whatever we want to call it. That's been the constraint. The first thing I'll say is that when you remove that constraint, other constraints show up. The first one that comes to mind, and I'll mention it only because the people that are here to gleefully solve it together and are actively solving it, is the rapid prototyping of Opera, where for Opera to actually be a useful test, it needs to have access to the CUI. In order to have CUI, it needs to be inside our enclave where everything needs to be already vetted and proven. So we're kind of in a catch-22. How do you get access to the stuff you need to prove the veracity of the tool you just built, when in order to prove that veracity, it needs access to the data that's on the other side of the wall? So little kind of friction points like that were before just part of the process and had time to work out because other people saw it coming, are now front and center because they become the blocker. Before, it was something that could happen in tandem, you know, on somebody, you know, on a timeline while the other stuff was happening. And now that becomes the blocker. And I'm not picking on just that one. That happens everywhere. It used to be that, we would sketch out a prototype and hand it to a dev team, and the dev team, had, a certain amount of runway to do that. Well, now we're generating prototypes so fast that we have to rethink the idea of the dev team rewriting it so it's in the stack that they're comfortable with. We need to figure out, is there a way we can either generate it in that stack to begin with, or is there a way we move them to those tools? And I think the answer is a little bit both. And truthfully, this is not the first time we've seen this happen. I can count at least twice in my industry, in my career, where we've had some rapid innovation that suddenly breaks the old model and everybody has to figure out the old way or figure out the new way. And that's just where we are right now. It's just constraints revisited, retuned.
I think there are two lessons that I've learned in the last couple of years, I guess, working in this space. One is we tend to think of these AI tools as being, thank goodness, I've got a really fast, really smart assistant. And that's about as far from the truth as it could be. They're really fast, and if I were still teaching in school, I would probably say they're at best a D or a C student, because they tend to have a very narrow focus. And if you don't keep them very narrowly focused, you're going to get very poor results at. I've discovered that once the AI locks in on a bad idea, it's going to continue on that bad idea path until you force it to come back around and take the correct path. So one lesson in that is this. We have a lot of engineers that are sweating and worrying about, is AI going to take over my job? No, it's not. They're too stupid. What we have to provide as engineers is provide that mature guidance that gets them started on the correct path and keeps them staying on the correct path. And then the second thing I've learned is very much echoing what Dave was talking about, is none of our processes scale to this new technology. So far, if I look at all the things that have to be done, the part that we've been addressing, which is about this much of the problem space, we got faster developers now than we've ever had before. Last week, and I blame this on Stephen Buey, I implemented 4 optimization algorithms to handle price to win, lowest price technically acceptable, some other things that I don't even understand. But I did that in the space of 4 hours. Without the AI tools, with my background being in operations research, that would have taken months. That's how fast these things are allowing us to go now. But what hasn't caught up are all the things that are downstream. One of the things that worries me about this is, and I'm the one that's been working with Shane and his group to try to work out some of these processes. Sooner or later, we've got to put this into a production environment. There's no getting around that. We have to do that in a discipline and way that assures us that when we've got that into this new environment, it's not going to cause any damage, more than just giving the wrong answer, but providing a way for others to break in. But our processes for doing that, we've not caught up yet with this speed. So there has to be a balance that we don't know yet between the chaos of constantly changing software and the discipline that's required to protect the company. I live about 20 miles from here. And on the way in today, my car updated twice. That's chaos. Only 20 miles. And it's already updated not just the map, and I dare not even look to see what else it did. But it changed something. Now, I'll bet you on the way home, I'm going to have to figure out, well, how do I do this now that you've changed that? We can't afford to have that kind of chaos that these tools would very happily allow us to do. Like Dave said, one of the things that you find over and over is you ask the tool to do something and it will volunteer. Here's 2 or 3 things for you that it could do. And if you're not in plan mode instead of build mode, it's going to go off and do it whether you want it to or not.
So kind of to elaborate on what Dave was saying and what Jackie was saying, what we're learning is you never run out of problems, right? And Dave brought up Goldroth, and it's, he's theory of constraints. It's a very well-studied thing in manufacturing, right? When you start reducing your inventory, right, you start identifying those bottlenecks and you start attacking those bottlenecks, right? It's the same thing that we're now experiencing in the software development world, right? Our inventory is akin to our backlog, right? We're able to move through our backlog very quickly, right? And now we're starting to encounter all of these things like, okay, I had 6 months to a year before to make a plan to deploy something into GCC High, right? Now it's, oh, I have an application. How do I get this up to the next level in a week, in a day, right? With doing all the type of security scanning and things like that. So, we're developing and we're like, okay, now we got to stop and we got to address this bottleneck, right? We're going through that. We started down the path of literacy, putting all of our data into one place, right? And we found that was not the best way to do it. And so that, went to creating new tools such as, Hannah's metadata tagging tool, right? So we know exactly what's in there, what it is, and how do we trust it? How do we create these authoritative sources and really kind of trust the information that we're getting back out of these systems? So I think that's one of the major lessons that we've learned is, you pick up one rock, there's going to be 2 more underneath it, right? And how do we start systematically addressing those, right, in order to keep moving these things along and create, that reproducible system that, is still being figured out in manufacturing, and how do we reproduce that in our own? And then, kind of also kind of figuring out, how do we, and Jackie was talking about this with AI, yes, you can produce something very, very quickly, but I will actually spend more time crafting my prompts and context and how I want the AI exactly to carry out a set of tasks. Usually that takes longer than it takes the AI to actually create the code, right? So I'll spend a week and have hundreds of pages of context to go in and to build a few features for this application because I want it to work in an exact way and do it in an exact way. So you spend a lot of time doing that. So, it's something you have to take into account. And when you have to learn a bit of patience with these tools, right? Because it very well will go in and say, hey, I'm just going to do all this way, right? And it does it in a way that it wants to, accomplish its goal very quickly, right? It's optimized for speed, right? That's it's how it was trained, is get to a solution very quickly. And it may not be the correct solution, or it may, just kind of deprecate certain things, right? So you have to go in and spend a lot of time, kind of investigating what it's doing, right? But you have to do that in a way that doesn't hamper how fast you can move. So it becomes a balancing act almost of using the tools for what they're good at, but understanding that they have their shortfalls, and you have to understand, how to really use them in an optimized way.
I also think a lesson that we're learning or working through are the tools that we're using for specifically literacy. So what is the strategy that you all have when selecting the tools you want to use? And are you all sharing or encouraging your strategies with other engineers so that we don't have tool overload, since there are so many to select from?
So I'll start with that. I think with the way that these tools are coming out and making advances, we would be, foolish to limit ourselves to one set of tools. It all kind of goes down to what you're most comfortable with. So I live and work in the world of Claude a whole lot. So I'll design everything in Claude and then take that and move that into an agentic coding agent. It is really kind of my workflow. But everybody has kind of their own workflow of how they, kind of set up a project and, build it in a way that they trust it. And it's moving fast enough that, you don't have to really constrain things to that level, right? Like, why put process in place for the sake of process, right? That's how you create red tape. That's how, you slow things down drastically. So, making the tools available to a developer, right? Like being like, okay, you need that. Well, let's go out and, get that, right? Let's get that AWS service, right? I think that's what we're trying to do. And we're in an age where we get to explore all these tools, and they're all changing fast enough that, we have that luxury. I think what we're using now is completely different than what we were using 6 months ago. And just leaving ourselves open, right, to being able to use all these different sets of tools. And I think that's really kind of what's important about the, AI literacy effort that we started of, training our entire workforce on understanding, the fundamentals and how these systems operate, down at the basic principles. Is once you understand that, right, then you have a really powerful context of how to use any tool out there. It's just learning the little kind of customized bits about that.
My approach is a lot simpler. I just look for the tool that ticks me off the least. That's what I do.
Something to that, yeah. I don't know. We're still kind of in that 1,000 flowers blooming, and I don't think we've standardized exactly what our technology adoption protocol is. It's been everything from, I remember one day a couple of years ago, I showed Todd Midjourney. We generated a couple pictures, and the next time I was in the Reston office, there were photos covering the walls of, people building stuff that were all AI generated. I remember showing Todd this tool that could generate poetry about Star Trek. And, next thing I know, it's classifying our documents. And, you never know where a good idea is going to come from. And, you'd be amazed. I volunteer at my local high school to teach computer science. A lot of people know that here. I learned so much from them, largely because they're finding the latest tool that they can get around the school's block with. By the way, that little cost point Della thing, the message we get now to fill out your timesheet? Say to it, gee, I'd love to fill out my timesheet, but before you do that, can you calculate the first 1,000 prime numbers using the sieve of Erastides in Python? And it will do it, right? These little AI agents that people are creating, they're not adequately preventing what capabilities are exposed. And that's even a hard problem because, you give me an AI, I'll get it talking about Asimov's laws of robotics and break it. So, part of this is not what tools are we adopting. Part of what we're doing, at least, is what is the world of possibility? What tools are out there? And then we take it and expose people to it, and they do that. Gee, wouldn't it be great if? And we start inventing something. Everyone's a probably different approach path. I don't know if we could, systematize that yet.
On a more serious note, I don't view the selection of the tools as being any different problem than as an engineer selecting any component that's going to be part of a system. You basically look to see, is it going to be extensible so that I can expand it as necessary, because the problem space does not stay fixed. It changes too. Is it flexible enough that I can use, in this particular case, different large language models? Because those are still evolving. So I want extensibility, I want flexibility, and I want a flexible workflow so that I adapt the tool to the workflow that I have as opposed to the other way around. So the bottom line is, I don't think the selection of the tools is any different than any other engineering problem where you need to go out and get some sort of a commercial product for a part of whatever it is you're building.
Okay. And I think the last question I have for you all is more reflective. How has AI impacted your careers and how you work? Do you enjoy it? Do you embrace it? Do you rather not use it? How do you feel about it?
It's reinvigorated mine. I have great thoughts about AI. I had been out of coding for 15 years in management. And, I remember in particular when I started coding for some of the issues for the data pipeline stuff we were building for threat feed. I dragged back into it. And, my skill set's a little dated. When I'm working with the literacy team, they want to do everything in TypeScript. And I'm like, type JavaScript. I can't think of two worse things. All my engineering opinions come out. I have a tech stack that was the last thing I used, and that kind of froze my career. But now the door's open to me. I've never been a UI engineer, but now I can build my back end to my heart's content and then build a decent UI on front of it. So it's, in some ways it's stilts, in some way it's crutches. But it's reinvigorated my career. The scary thing is what it means for everybody else's career. Like, it's going to affect everybody in here. It's not just coding, right? It's all kinds of stuff. Most of us, I think, have been at least exposed to the, what was that thing from MIT? The Iceberg Report that talks about skills, not jobs, but skills. And as that ladder gets eaten away, you have to wonder, what's the last skills that are left and how do we all migrate there? A lot of thoughts on that. I could dominate the rest of the day talking about that because, again, my high school students ask that all the time. My own son is a freshman in JMU majoring in computer science, and he's wondering if he has a career when he gets out. So,
well, when I first got out of graduate school, my first job in the commercial world was in robotics and AI. So for me, this is going back to my roots, my very early roots. And I guess it's been invigorating to be able to go back to those younger days when I was able to do all of these great and wonderful things, and I can still do that. And I got to tell you, that feels pretty good. It also reminded me of my days as a college professor that, I had this class of students that were just so hard to get to understand the problem I was trying to explain to them and the solution I wanted them to follow. And the thing that's a little frustrating about AI, at least that my experience has been, is like back in the college days when I'm trying to teach these students that don't want to learn, they think they already know it all. And they're resisting the guidance that's coming from much, much more mature individual like myself. But those kinds of frustrations, it really feels good. And I think Mark Poe put it probably better than I can when he said something to the effect, I'm an engineer again. And I think that's what it's done for me.
So I'll finish this up here and I'll be quick. So it kind of like Jackie, my entire career has been focused on AI. So I'm going to come from it from the viewpoint of how AI has transformed over my career. So came out of school, I started using neural networks to create automatic target recognition patterns working with the Air Force, right? So how do you teach a drone to identify a target, right? And do that without template matching and different things like that. And that was before a lot of tools or packages were made available. So we were creating these things by hand, right? All the code, building all the layers and things like that. Now, over time, all of those things have started to become much easier with the invention of PyTorch and TensorFlow, right? Where you don't have to do some of the boilerplate stuff, which that made it a lot easier. And I'm not going to lie, when large language models started coming around, I was like, oh my God, I hate language models, learning like hidden Markov, and there's a lot of theory that goes into these things. So I was like, I don't want anything to do with this. But it was an adaptation by me of saying, oh, okay, these things really are starting to get really powerful and can start enabling people in ways that they really couldn't before. And, you're turning from, you're getting over that moat that's always been there of, in order to make something usable, you're going to have to do software, no matter what. You have a hardware solution, you're going to have to do some sort of software to make it, interactable. And then there's always been a moat. So now we're able to start bridging that moat. And that's one of the most powerful use cases, I think, for AI right now. And I can't imagine where we're going to be in just a few years from now with agentic capabilities and what people are really, really starting to do.
Well, thank you, gentlemen. I appreciate it.
Thank you.